Today's lesson, heat of neutralization is more than the constant value. What does it mean? Let us have a look. Constant value of heat of neutralization is delta H is equal to minus 57.34 kilojoule. This is known as heat of neutralization, and this is constant for strong acid, suppose hydrochloric acid, and strong base, suppose sodium hydroxide. When 1 mole strong acid is treated with 1 mole strong base, 1 mole strong acid hydrochloric acid is treated with 1 mole strong base sodium hydroxide, then sodium chloride is formed. At the same time, in this case, 1 mole water is formed. With the formation of 1 mole water from this reaction, this amount of heat evolves 57.34 kilojoule. This is known as heat of neutralization, which is constant for strong acid and strong base. Today's lesson is when and why this value gets higher. This is today's lesson. So let's go to the detail. When this value increases, if hydrofluoric acid is used instead of strong acid and base is sodium hydroxide. Actually, when hydrofluoric acid is used, then this constant value increases. Now let us see why it increases. Here, sodium fluoride salt is formed. At the same time, water is formed. Here, water is not 1 mole because hydrofluoric acid is a kind of weak acid. That is why it doesn't ionize completely to form proton and fluoride ion. Here actually hydrogen ion is not 1 mole because hydrofluoric acid doesn't dissociate thoroughly, but hydrofluoric acid absorbs some amount of heat which is provided from the reaction system. In that case, hydrofluoric acid ionizes fully to form 1 mole protons, and in that case this constant value decreases a bit. But now protons 1 mole, sodium hydroxide, which is a kind of strong base, it ionizes completely to form sodium ion and hydroxide ion. Here 1 mole hydroxide ion. Now 1 mole protons combine with 1 mole hydroxide ion to form 1 mole water, and we know to form 1 mole water, the reaction of acid and base at room temperature, the amount of heat which is produced is known as a heat of neutralization, and in this case this is 68 kilojoule. Now let us see why this is 68 kilojoule, that is why this is more than this constant value. Now let us see why this is more than the constant value. Here we got that sodium fluoride is a kind of salt which is a kind of strong electrolyte that ionizes fully to form sodium ion and fluoride ion. That is, actually sodium fluoride remains as ions, sodium ion and fluoride ion. Now let us see about fluoride ion. Fluoride ion. Fluorine is a kind of smaller atom, extremely smaller atom. That is why fluoride ion carries a high electron density. Here electron density is very high. That is why fluoride ion is hydrated in this way. Hydrogen becomes positive in charge. This hydrogen becomes positive in charge. Here hydrogen bond is formed. As fluoride ion carries a high electron density, these hydrogen bonds are strong bonds, strong hydrogen bonds. As these hydrogen bonds are strong hydrogen bonds, from these bonds energy released is higher, which is known as hydration energy. Because of the higher hydration energy evolved when fluoride ion is hydrated by water. Then higher amount of hydration energy evolves. Because of the higher amount of hydration energy, ultimately this constant value increases, though initially it decreases because hydrofluoric acid absorbs some amount of heat, but finally it increases up to 68 kilojoule because this reaction produces sodium fluoride salt. Sodium fluoride salt is a kind of strong electrolyte which ionizes to form sodium ion and fluoride ion. Fluoride ion carries a high electron density. Because of the high electron density, fluoride ion forms strong hydrogen bonds with water. Because of these strong hydrogen bonds, fluoride ion evolves a higher hydration energy. That is why ultimately constant value increases up to 68 kilojoule. This is the reason heat of neutralization is more than the constant value when hydrofluoric acid is used instead of strong acid. That is when hydrofluoric acid is used instead of a strong acid, and why sodium fluoride ionizes to sodium ion and fluoride ion, because of the fluoride ion which is smaller in size. So one is smaller in size. Number two, fluoride ion carries a higher electron density. That is why heat of neutralization increases up to 68 kilojoule, which is more than the constant value. This is all about heat of neutralization is more than the constant value. No more today. Thank you very much.